Hello, this is lesson 0.4, Introduction to Development of the Learning C++ app on iOS, the link of which is in the description. Before we can write and execute our first program, we need to understand in more detail how programs get developed. Here is a graphic outlining a simplistic approach. So, this is the what step, where you figure out what you're going to solve. So, coming up with an initial idea for what you would like to program can be the easiest step or the hardest, but conceptually it is the simplest. All you need is an idea that can be well defined and you're ready for the next step. The step 2 is determine how you're going to solve the problem. This is the how step, where you determine how you're going to solve the problem you came up with in step 1. It is also the step that is most neglected in software development. The crux of the issue is that there are many ways to solve a problem. However, some of these solutions are good and some of them are bad. Too often, a programmer will get an idea, sit down, and immediately start coding a solution. This almost always generates a solution that falls into the bad category. Typically, good solutions have the following characteristics. They are straightforward, they are well documented, they can be easily extended to add new features that were not originally anticipated, and they are modularized. Now, the third and the fourth bullets are the bigger problems. While it's possible to generate programs that are straightforward and well documented without using a lot of for, though, designing software that is extensible and sufficiently modularized can be a much tougher problem. As far as extensibility goes, when you sit down and start coding right away, you're typically thinking, I want to do this. You never consider that tomorrow you might want to do that. And studies have shown that only 20% of a programmer's time is actually spent writing the initial program, while the other 80% is spent debugging, which means fixing errors, or maintaining, which means adding features to a program. Consequently, it's worth your time to spend a little extra time upfront before you start coding, thinking about the best way to tackle a problem and how you might plan for the future in order to save yourself a lot of time and trouble down the road. Modularization helps keep code understandable and reusable. Code that is not properly modularized is much harder to debug and maintain, and also harder to extend later. We will talk more about modularization in the future. Step 3 is to write the program. In order to write the program, we need two things. First, we need knowledge of a programming language. That's what these tutorials are for. And second, we need an editor. It's possible to write a program using any editor you want, be it Windows Notepad, or Linux Gedit, or Mac's Xcode, or we'll talk about these later. But however, we strongly urge you to use an editor that is designed for coding. What do I mean by that? A typical editor designed for coding has a few features that make programming much easier, including line numbering, for example. Line numbering is useful when the compiler gives you an error. A typical error will state error, let's say line 64. Without an editor that shows the line numbers, finding line 64 can be a real hassle. Second, you have syntax highlighting and coloring. Syntax highlighting and coloring changes the color of various parts of your program to make it easier to see the overall structure of your program. The third important thing is that you have an unambiguous font. Non-programming fonts often make it hard to distinguish between the number 0 and the letter O, for example, big O, between the number 1 and the lowercase l or uppercase I. A good programming font will differentiate these symbols in order to ensure one isn't accidentally used in place of the other. Your C++ programs should be called name.cpp, where name is replaced with the name of your program. The .cpp extension tells the compiler and you that this is a C++ source code file that contains C++ instructions. Note that some people use the extension .cc instead of .cpp, but I recommend you to use .cpp. Also note that many complex C++ programs have multiple .cpp files. Although most of the programs you will be creating initially with me will only have a single .cpp file, it is possible to write single programs that have tens, if not hundreds, of individual .cpp files. We're now up to step 4, which is compiling. In order to compile a program, we need a compiler. The job of the compiler is twofold. The first is to check your program and make sure it follows the syntactical rules of the C++ language. The second is to take your source code as input and produce a machine language object file as output. Object files are typically named name.o or name.obj, where name is the same name as the .cpp file it was produced from. If your program had 5 CPP files, the compiler would generate 5 object files. Now I think it's time for me to show you a second picture that illustrates what I just said. As you can see, every source file, when compiled, will produce an object file. Now, for illustrative purposes only, most Linux and Mac OS X systems come with a C++ compiler called G++. To use G++ to compile a file from the command line, we would do this. G++ -c file1.cpp, file2.cpp, file3.cpp. This would create file1.o, file2.o, and file3.o. This -c means compile only, which tells G++ to just produce .o files. Other compilers are available for Linux, Windows, and just about every other system. We will discuss installing a compiler in the next section, so there is no need to do so now. For complex projects, some development environments use a makefile, which is a file that tells the compiler which files to compile. Makefiles are an advanced topic, and entire books have been written about them. We will not discuss them in these tutorials. Let me get back to the figure 1 and show you that step 5 is to linking. Linking is the process of taking all object files from a program and combining them into a single executable. For that, I will show you this picture. In addition to the object files, for a program, the linker includes files from the runtime support library, as you can see from this graph. The C++ language itself is fairly small and simple. However, it comes with a large library of optional components that may be utilized by your program. And these components live in the runtime support library. For example, if you wanted to output something to the screen, your program would include a special command to tell the compiler that you wanted to use the input-output routines from the runtime support library. Once the linker is finished linking all the object files, assuming all goes well, you will have an executable file. Again, for illustrative purposes, to link the .o files we created above on a Linux or OS X machine, we can again use the G++. Do that is by doing something like G++, -o prog file1.o, file2.o, file3.o. The -o tells G++ that we want an executable named prog that is built from file1.o, file2.o, and file3.o. The compile and link steps can be combined together if desired. For that, we would do G++ -o prog file1.cpp, file2.cpp, and file3.cpp, which will combine the compile and link steps together and directly produce an executable file named prog. Back to the graph that shows the steps. The step 6 is testing and debugging. This is the fun part, hopefully. You're able to run your executable and see whether it produces the output you were expecting. If not, then it's time for some debugging. We will discuss debugging in more detail soon. Now, I need you to note something, that steps 3, 4, 5, and 6 all involve software. While you can use separate programs for each of these functions, a software package known as an Integrated Development Environment (IDE) bundles and integrates all of these features together. With a typical IDE, you get a code editor that does line numbering and syntax highlighting. The IDE will automatically generate the parameters necessary to compile and link your program into an executable even if it includes multiple files. When you need to debug your program, you can use the integrated debugger. Furthermore, IDEs typically bundle a number of other helpful editing features, such as integrated help, name completion, class hierarchy browser, and sometimes a version control system. We will talk more about installing and using IDEs in the next section. This is the end of lesson 0.4. See you next time.